All right, here, let's do another example of writing logarithmic expressions as a single log. So let's do A. So again, we're looking at combining all of these. So here's what I would do now. So let's do it a different way. Let's deal with this. So let's write these as exponents, right? So this is going to be log of a to the third minus log b to the 1/2 minus log of c to the 1/2. Okay, and then I'm going to deal with these two. So this is going to be what, log, so log of what? This is going to be a cubed divided by b to the 1/2, okay, minus log of c to the 1/2 power. And so now I'm going to take this minus this, okay, so it'll be this divided by this, which will give me log of what? A cubed divided by b to the 1/2 power all over c to the 1/2 power. But if I write this as a, instead of dividing, I can write it as a product of the reciprocal of the bottom here. And so what happens is the c to the 1/2 ends up going to the denominator. Let me show you this way. So here, if I have a to the third over b to the 1/2 all divided by c to the 1/2, I can write the c as it's over 1, right? So I've got a fraction divided by a fraction. So I can write this as, instead of a division, right? Instead of this divided by this, I can write this as a multiplication problem. So I can, by multiplying by the reciprocal of the bottom. So it's a cubed divided by b to the 1/2 times what? 1 over c to the 1/2. So the c to the 1/2 power ends up being on the denominator with the b variable. So this will just end up being log of a cubed over b to the 1/2 times c to the 1/2, but they're both to the 1/2, so we could write this as yeah, well, let's write it separately. We could, so b to the 1/2, c to the 1/2, right? And then what I could do is, since they're both square roots, so they both are square roots, so we could just combine them. So this will end up being the square root of BC on the bottom. And that's it. Now let's do B. Now let's do the same thing, right? So I'm going to write this as natural log of x to the 1/2 power plus natural log of x squared minus 1 minus natural log of x plus 1. And so now I'm going to combine these two. So this will be the natural log of x to the 1/2 times x squared minus 1 minus the natural log of x plus 1. Okay, now I'm going to combine these by using the subtraction. So it's going to be using the quotient rule, or the quotient property. So this is going to be natural log of, now we're going to get x, let's change this to the square root of x, since that's what it is. So square root of x times n x squared minus 1. Notice that that's a difference of 2 squares, so we'll factor that out. And then we get x plus 1 on the bottom. Okay, now I'm going to simplify this. So this is going to equal natural log of x, square root of x times what? X plus 1 times x minus 1. And then all over x plus 1. And then the x plus 1's cancel. And so my final answer is going to be the natural log of what? Square root of x times x minus 1. Okay, now notice that the domain, okay, if you look at the domain of each one of these, remember it has to satisfy the domain of each one of these. So this one has to be greater than 0. This one has to be greater than 1 or less than negative 1. Okay, and then this one has to be less than negative 1. Right? So whatever term has the restricted domain, right? So it has to be an intersection of all three of these. So in this case here, greater than 0. This one has to be greater than negative 1. So this has to be greater than negative 1. I think I misspoke. This one has to be greater than negative 1. This one has to be either less than negative 1 or greater than negative 1. And this one has to be greater than 0. So the one that restricts it the most is this one. So it has to be greater than 0. But down here, if you notice the same thing, this has to, inside here has to be greater than 0. So it can't be negative, right? So, and it can't be 0. Or wait a minute, hold on. Yeah, it can't be 0. So, in this case here, x can't be 0, and x has to be greater than 0 here. X has to be greater than 1. So that means this, in order for this to work, the domain of this one has to be greater than 1. Okay? So just realize at the end, what the domain is, the restricted domain is, that might be to make it work.